Alright, hello everyone. So let's solve a couple of challenging problems from squeeze theorem, or what we call the sandwich theorem. So the first example is given to you, this sequence 2 to the power n over n factorial. Okay, so rather than calling it an, let's call it y sub n, because we already learned that we need to find two sequences such that yn is in the middle. So you need to find the two sequences. One sequence is larger than yn and the other sequence is smaller than yn. So let's have yn in the middle. 2 to the n over n factorial. Okay, so let's start with the easiest scenario. Well, I guess we can easily find a sequence less than 2 to the n over n factorial. What do you think? Tell me a sequence. Well, I will split it out for you. 1 over n factorial. What do you think? It's always smaller than 2 to the n over n factorial, right? So let's write like the nth term of the 2 to the n over n factorial. So it's going to be 2 times, 2 times, 2 times until n times over 1 times, 2 times, 3 times, 4 times, 5 times. N factorial means you multiply until n, right? Okay, so if you take away the numerator, you can see numerator is always 2, then it becomes 4. So numerator is getting large. So if you get rid of numerator, you can see 1 over n factorial is always going to be smaller than 2 to the n over n factorial. I hope you can see that. All right. Now, finding a sequence that is larger than 2 to the n over n factorial is the harder problem, okay? So to do that, what I'm going to do is I'm going to write the terms of this sequence. Let me make space. Okay, so if you write the terms of this sequence 2 to the n over n factorial, like the nth term. So it's 2 times, well, I already had it there, right? Okay, so it's going to be 1 times, 2 times, 3 times. All right, so and so on. Let's write few terms. Now, here's something that you want to digest. So what I'm writing here is the nth term, just a one specific term of the sequence. So you want to find a larger sequence means if the nth term is larger than nth term of 2 to the n over n factorial, that means if this term is smaller than the term that you're going to find, then that's enough, right? Okay, all right. So we want to find a sequence, an nth term of a sequence that is larger than the nth term here. So what I'm going to do here is, listen carefully. So this 2 and 2 cancel out, you can see. So it's 2 times, rest I'm going to write it inside parentheses. 2 over 3, and it's 2 over 4, and it's 2 over 5. Can you see that? And it's 2 over 6, and the last term will be here. N over, so 2 over n, right? Okay, perfect. Now here, if you notice, the numerator is fixed, it doesn't change, but the denominator keep increasing. Now what happens when denominator keep increasing? What happens to a fraction? If the denominator increase, the fraction gets smaller and smaller, right? I mean, this fraction is larger than this fraction. 2 over 4 is larger than 2 over 5. Okay, 2 over 5 is larger than 2 over 6. So the fractions are getting smaller. Now tell me this. What is the largest fraction out of this collection? So you have 2 over 3, 2 over 4, 2 over 5, 2 over 6. You can keep on writing. But who's the largest? 2 over 3, right? Can you see that? Because 3 has the smallest denominator. Smaller the denominator, larger the fraction. So you want to find something larger than this whole thing, right? So 2 over, I'm going to say this, what I'm going to write here is larger than what we have here. So instead of 2 over 4, I'm going to have 2 over 3. Because 2 over 3 is larger than 2 over 4. Instead of 2 over 5, I'm going to have 2 over 3. Instead of 2 over 6, I'm going to have 2 over 3. And 2 over 3 forever. Not forever, until the nth. What do you think? This, what you get here, is larger than what you had here, right? Can you see that? It's all based on the argument that when the denominator is increasing, the fraction is getting smaller. So why not we have our denominator to be 3? So you can see each term is larger than or equal to what we have here, right? Okay, perfect. Now let's write the general expression of this term. What do you think? It's 2 times, how many terms we have here? What do you think? It's definitely 2 over 3 to the power what, some kind of a power. What is it? Is it n or n minus 1 or something else? Remember, we have n terms here, right? We write until n because this is the nth term. But inside here, see, this is a one term. So it's actually what you have here is n minus 1. But not only that, be careful, we cancel out one term, we cancel out 2 over 2. So we lost 2 terms, right? So here we had total n terms. So this 2 term, with this 2 term, it's n minus 1. Removing this 2 over 2 term, it's n minus 2. So this is 2 over 3 to the n minus 2. Okay, so the sequence 2 to the n over n factorial is smaller than 2 times 2 over 3 to the n minus 2. So that's the trick. So our sequence that is larger than 2 to the n over n factorial is 2 times 2 over 3 to the n minus 2. Try it by yourself, try to digest it, okay? Alright, so that was tricky, right? The way we found this larger sequence. Okay, the limits now. Well, this doesn't work if our limit is not same. So limit of 1 over n factorial, guess what? When n gets large, the total fraction gets smaller and smaller, so it approaches to 0. So, right? So the limit of this lower sequence is 0. What is the limit of the higher sequence? 2 times 2 over 3 to the n minus 2. Well, 2 over 3 is a number smaller than 1, right? It's like what, 0.6? Yes. So when you keep on taking the powers of 0.6, it's getting smaller and smaller, right? Approaching to 0. So the limit here is also 0. So limit here is also 0. So guess what? What is the limit of, I'm running out of space. Am I? So the sequence is yn 2n over n factorial. So the limit of this sequence is also 0 because of the squeeze theorem. Okay. So this sequence is convergent to 0. Alright. Okay. So that was a fun problem. Well, I promised you I would do another one. So here's the other problem. N factorial over n to the power n. So this is the other example. So we want to find two sequences that are larger and smaller than n factorial over n to the power n. Tell me a smaller one. When numerator is large, right, n factorial, if we get rid of that numerator, if we replace it by 1 because 1 is smaller than n factorial, so then we can easily create a smaller sequence. So that was easy, just like the first case. Now the game is to find a sequence larger than n factorial over n to the power n. So let's write the nth term here, okay? So the nth term here, again I'm writing the nth term, 1 times, 2 times, 3 times, so n factorial, 4 times, blah blah blah, and the last term will be n. And n to the power n means n times, n times, n times until n times, right? You multiply n by n times. Okay, so I'm gonna write this as 1 over n. I'm gonna filter it out, this 1 over n, okay? And the rest is 2 over n, 3 over n, 4 over n, and this n cancel out, right? So the last term will be what? N minus 1 over n, right? So we were going until n factorial here, right? So you cancel out the n, denominator is always n, so the term before n is n minus 1. So that's what left. Alright, so now you want to find a sequence, a term which is larger than everything here. So what do you think? So here's the scenario. If you look at this part, it's getting smaller and smaller, right? 2 over n, 3 over n, 4 over n, right? Remember, n is a larger number than 2 here, okay? N minus 1 over n, the largest fraction here is also less than 1. My point here is this fraction here is less than 1, 3 over n is less than 1, 4 over n is less than 1, n minus 1 over n is less than 1 because n is greater than every numerator here. So you are multiplying 1 over n by a number that is smaller than 1. Bunch of numbers smaller than 1. So tell me, isn't 1 over n is larger than what you get as the outcome of this result? Think about it. You have 1 over n, you multiply 1 over n by 2 over n. Okay, 1 over n is definitely larger than this. I'm sorry, 1 over n is definitely larger than 1 over n times 2 over n, simply because 2 over n is a number less than 1. You multiply by a decimal. Think about it. Okay? Alright. So 1 over n, it sounds absurd, right? And I'm not sure whether absurd is the correct word or not. Unusual, right? But it is the case. 1 over n is larger than what you have here. So the sequence greater than n factorial over n to the power n is apparently 1 over n. So limit of 1 over n to the n, here the limit is 0, right? When n gets large, 1 over n to the n will get smaller and approach to 0. Of course, limit of 1 over n is 0, right? So guess what? What is the limit of n factorial over n to the power n? Is 0 because of the squeeze theorem. So this sequence is convergent to 0. Alright, interesting, right? So two interesting examples of squeeze theorem. Okay, so they are challenging, little bit challenging. There are a little bit of thinking process to do, but they were fun examples. Okay, alright, I hope they made sense. If they didn't, spend some time on it. Okay, I'm sure you will figure it out. Okay, just go with the idea that I presented. Just test some numbers. Choose a number for n, like think n as 5 in both cases, and just test it out and you will see. Alright, okay, thank you very much. Bye bye.